Next, let us talk about alpha channel. Alpha channel is what we call the transparency value of pixels. It is the opposite of opacity. If transparency is, let's say, 30%, then the opacity is 70%. Transparency value indicates how much the pixel reveals the pixel behind it if overlap. This idea is very important when you put an image in a website with a background. If the image has some transparency value, then the background may be able to be seen up to certain transparency level. And it is also the concept that you need to know when you are doing image composition with uh, layered based technique, for example in Photoshop. And opacity value indicates how much the pixel hides the image behind it, so it is opposite. Alpha channel is also information that we need to keep, so it is the extra value that some image formats add to its representation of pixel beside the value of the color model it uses. Example, these are two pictures of the late Princess Diana. This one is the original one, and then I remove the background. I use Photoshop and I make the background transparent, so this is how it looks like. The grayish yellow background color will appear transparently in the background. So this is what I call alpha channel. Next, let us talk about image size. This is about how much size, how much RAM we need to keep the image information. This is not about the dimension, the width and height. There is a concept of color depth. First, let us look at the monochrome color. Monochrome means black or white, or may also include the grayscale in between. 1 bit monochrome is actually a pure white and pure black detailed arranged in such a way that even though it is pure white or pure black, we can still produce color that is in between, the gray in between, by putting more white in the light area. In the dark area, we put less white or more black. This is what we call dithering. 2-bit dithering will make the grayscale more smooth. So just now was only 1 bit per pixel or 2 bit per pixel. For colored image, we can have many bits per pixel. For example, we have a concept of what we call high color or thousands of color. Let's say in RGB color model, we have total 15 bit for it. So it means 5 for red, 5 bit for green, 5 bit for blue. And the extra for 16 bit maybe just the alpha channel bit. So if we are using 15 bit total, there will be 2 to the power of 15 number of colors. That is 32,000 colors. That's why we call it high color. And this is close enough to true color. But the true color is the one that use 24 bit per color channel. This is millions of color. 24 bit means 8 bit for red, 8 bit for green, 8 bit for blue. So the total is 60 million colors, more or less. And the color that it produces is indistinguishable by human eye. If there are two colors that has only one bit different from each other. That one bit different will not be distinguished by human eyes. That is for true color. Most of color system nowadays are using 24-bit or millions of color or true color. Now it is image display size, the main idea for this topic. Display devices need memory to keep the images it displays. The size in bytes of the required memory is calculated as width multiplied by height, of course, the number of pixels, and then how many bytes per pixel. So that will be the amount of memory that the display size needs. Byte per pixel is number of color multiplied by bit per color divided by 8. If this is in byte, we don't have to divide by 8. And alpha channel is counted as a color channel. It is an addition to RGB. So alpha channel is a fourth color. And in fact, in some programming language, they don't handle RGB, but they handle RGBA. A is for alpha channel. Example, calculate the display size for a 4-bit grayscale image with 4-bit alpha channel with 100 pixel width and 50 pixel height. So maybe we calculate the number of bit per pixel first. So 4-bit for grayscale, this is not color, it's grayscale, and 4-bit for alpha channel. The total is 8-bit per pixel already. So 2 multiplied by 4 is 8. It's actually 4 plus 4 divided by 8 is actually 1. So it's 1 byte per pixel. So it is easy. 1 multiplied by 100 by 50, it is 5000 bytes. Next, finally, let us talk about image format. Image formatting is a scheme to store pixel values in a standard way as files. The concept of rastering or the concept of arranging pixels in image is the same for any format. But how the information is stored, how the information is arranged, that will be different from format to format. Image can be stored as raw data, which means we keep the pixel as it is, no compression, and we just put it as 2D matrix. There are cases where we keep image data as raw data, and in Windows, the format for this is .bmp. Before we continue with the image format, let us talk about two terms in data compression, that is lossy and lossless. Lossy means when we take the original data, we compress it, and then we decompress. The data that comes out after decompressing is not the same as the original data. That is lossy because we lose some data there. Original, compress, then decompress. The data that is obtained after decompressing is not the same as the original one. But lossless, meaning it's not lossy, no information loss. When we take the original data, we compress it and decompress, the data that we obtain after decompressing is exactly the same data that we originally compressed. So that is lossless. All practical image formats employ compression because image nowadays is quite big. First format, JPEG or JPG, stands for Joint Photographic Experts Group. It employs lossy compression using 2D DCT or discrete cosine transform. It is a kind of Fourier transform. Doesn't support alpha channel. Doesn't support animation of frames. The compression and bits per pixel per channel can be adjusted. Normally, you can see this when you export image from Photoshop or Photopea. You can specify how much compression you want. More compression, the image becomes more blurred because less data has been saved. You want a high quality picture, you need a lower level of compression. So if you are looking for image format that give highest compression ratio, JPEG is the choice because this is the one that's actually designed for compression. Next is GIF.gif, stands for Graphics Interchange Format. It is a proprietary of a company named CompuSoft. So if you want to produce .gif file, you need to pay royalty to this company, but if you just want to use a view.gif, it is free. This format use not number of bit per pixel to keep color, but it keeps color as palette. There are 256 color in the palette. It's basically each pixel contains only 8 bit of data. It supports 1 bit alpha channel, means each pixel can either be totally transparent or totally opaque. It supports animation frames. I think many of you have seen animated GIF in social media. It employs lossless compression as opposed to JPEG that use DCT, which is lossy compression. GIF employs Lampel zip Welch compression. The compression can be adjusted. If you want more compression, you can just reduce the number of color in the palette. Because this is palette based color, if the image is having more than 256 color, the image quality will be low. And if that is so, dithering will be employed, which means, let's say if the image is a natural image, definitely will have more than 5,000 color, for example. So color beyond 256 in the palette will be produced by dithering colors out of this 256, which will deteriorate the color quality. Next format is PNG, stands for Portable Network Graphics. It is open source version of GIF. It keeps true color like JPEG or can be palettes like GIF. It supports multi-bits alpha channel, not only one bit like GIF. Also support animation and frames, but so far I don't see any application or web page that actually animates PNG, because you see, even though we have resource of animatable image like PNG, but if there is no application that support the feature that it has, you won't find anyone using it. And it employs lossless compression. Last one is bitmap. As we said just now, it is raw format. It does not employ any compression. Hence, it is a format that produces largest file, does not support alpha channel or frames. It keeps the original uncompressed color value, but least useful for internet due to its size. So why people still use .bmp? The reason is because for medical or scientific imaging, we cannot compress the image because maybe there is one single dot in the image there. If we compress it, that important single dot may disappear. So in research, for example, in the image that we get from Hubble telescope, one small dot of star might be important and we cannot compress it. Also in mammogram or in X-ray, we normally don't compress it because one small dot in the X-ray may actually show some sickness and it may disappear if we compress it. And there are a lot more other formats like .tiff, raw, ppm, and so on. This one is left to you to explore yourself because these are the less popular formats. And most of these formats are well documented, so they are easy to convert to each other. It's left to you to explore this. Converting image online is quite easy because image is not as large as video. So uploading image for converting online is quite easy and there are so many free web page that converts image format nowadays. The converter can be part of a big application. For example, you import a GIF file in Photoshop, you can save it as JPG. It can be a standalone converter. You can install an app that only does image conversion, or it can be just, as we said just now, a web-based application. It is left to you to explore.